Good morning, everyone. I hope you are well. We had a bit of a false start this morning, so apologies for that. This morning we are joined by Peter, who is going to look at embedding maths conversions or measurement conversions in our vocational lessons. So Peter, over to you.
Thank you, Sarah. Good morning, everybody. Bit of maths to start the day. What you can see on the screen there is a bit of a horror show that we have in the college, and this is a long-standing problem in the college that come summer GCSE exams, our students are not successful in doing basic metric conversions. So this is one from summer 2025, so last summer, and 416 of our students could not convert 60 millimeters into centimeters. So I'm going to talk a little bit about that today and how we can all help with that. So first and foremost, this is a problem for every classroom, not just the maths classroom, because you are all using metric conversions. So I'm going to talk a little bit about the scale of the problem. I'm going to talk about how place value is taught. And if you're not sure what I mean by place value, then that'll be clear when I go through it with you. And I'm going to give you some tools and techniques to help you with improve students' fluency in their vocational lessons so that we're not in this situation when the results come out in August this year. Okay. So we have huge numbers of students here who nearly get grade 4s in maths. And this little table here is the first 6 students I looked at. First 6 students who'd got grade 3s. Now we have hundreds of these, and I really mean that. I only had to look at the first 6 students here. And they've all got between 36 and 47 marks. Anyone who's scoring that, their maths is decent. Their maths is okay. They could be able to get a grade 4, but haven't. And in the final column there, what I'm showing is the number of marks that these students lost in the first 6 questions of the first paper. And as you can see, they're relatively straightforward 1-mark questions. And included in that is this relatively straightforward conversion of 60 millimeters into centimeters. And if we can get these simple questions turned around, then we have the potential to hugely move the dial in the number of our students that get grade 4s. So I'm just going to concentrate now on these metric conversions. So I'm just going to talk a little bit about place value, because what we're doing in these conversions, we're doing things like multiplying by 10, multiplying by 100, multiplying by 1,000, dividing by 100, divided by 1,000. And this is what we call place value. And our students, this is a key misconception area for our students. And in particular, they have a very fragile understanding of what value places have once we move to the right of the decimal point. So let's just see what I mean. What am I talking about here with place value? So that's the sort of graphic that we would use in the classroom when we're helping students. And I've put no zeros in there at all. And we'd start by asking students, what is that number there? And the number that's being shown there is 40, because we have a 4 in the tens column. If we want to multiply that by 10, we move it 1 place to the left, 1 place bigger. So that 4 is now in the hundreds column. If we want to divide by 10, we move it 1 place smaller, 1 place to the right. So that 4 in the tens column now becomes a 4 in the ones column. So that's at our basic level of working with students to understand place value and how we multiply and divide by multiples of 10, 10, 100, 1,000. Now we move on from that sort of fairly simple representation, and these are pictures of some of the whiteboards that we use in the classroom, and you'll see there that I've got at the top line there is the same representation that I've just shown you, but we're making connections now with place value and some of the other concepts that students need to know. So in line A, those are the values we were just talking about, the tens column, the hundreds column, the ones column. And as you can see, once we move to the right of the decimal point, we've got the 10th column, the 100th column, and the 1,000th column. In line C, you'll see that students are starting to familiarize themselves with these concepts, making connections with percentages, so they can see where the 100% column is, the 10% column, the 1% column. And percent is important here because we're seeing the same root word, cent, as we see in centi for centimeters. You'll see in line D, we're helping students make connections with money there, very topical at the moment, price of money, price of petrol at the petrol station. And so we even include 0.1 of a penny there to help students understand what's going on there. And on this final row that I've shown here are our metric prefixes, so that students can start to think about where the kilo, the K column is, where the centi, the C column is, and where the milli, the M column is. Now I'm giving you a very fast rush through of this. This is stuff that we have to go through very slowly and methodically with our students. Now I've ringed kilo, centi, and milli because those are the only three in our metric system that our students need to be familiar with for their exams. It's a slight shame because if they did have to deal with hecto, deca, micro, it would make life a little bit easier for them to sort of see the whole structure. But we just focus on those two. Certainly students working in health and social care need to understand micro for drug doses and things. So that's the nature of the problem. How can you help in the classroom? Well, I'm not expecting you to go and do that sort of work in the classroom, but I just wanted you to have an idea of where we are in the maths classroom. What I want you to be doing is, wherever possible and whatever curriculum area you're in, you will have measurements of some sort or another. Every lesson, please, quick oral questions. How many centimeters in a meter? So how many centimeters are there in whatever, and vary those. You'll see I've given examples here, 2 meters, nice round number, 3.1 meters, complicated a bit, add a decimal in, 2.5 meters, complicated again, add in a fraction. See how the students do. Next technique that you can use, whenever you're giving instructions, so if you're working in the kitchen, give some of your measurements in kilograms, some in grams, so that students have to work between the two, and give them units they're not necessarily expecting, so you're forcing conversion. If you're working in the lab, switch between liters, milliliters, so on and so forth. Now, when we ask these questions, please ask lots and lots of questions. Ask the same question to lots of students. Don't acknowledge immediately whether the answer's right or wrong. We don't get focused on right and wrong. Be very sensitive to students' maths anxiety. This is a stress area for students. So being wrong is fine. That's how we learn. Make sure there's no ridicule, no shouting out. Give time for students to answer with questions like this. This is stuff that they struggle with. So the first thing you can do is a lot of rapid fire questioning like this, in that the more and more this happens every lesson, every day, the students will get this in the end. Now, I've also got a couple of digital tools for you, and the links are here. I'll just have to show you these. So the first one is a online ruler that you can get up on the screen, and you can move the green line and the orange line along, and this is actually just asking students to read off a ruler, and you will be surprised how much students struggle with this. This is something that a lot of students have hidden during secondary school, something that they should have learnt in primary school. Okay, so be very, very patient with them. Each of these has a little reveal on there, so we can see we use this in the maths classroom. So as well as the exact reading and the exact millimeters, we might be asking them to do some rounding. You know, what's that to the nearest centimeter? So they can actually see, you know, what nearest means. It means physically nearest, and you can play with these. Now it's very unusual for me to actually have to develop resources, but this is such a serious area for us that I actually had to develop that ruler. So if there's anything you don't like about it, it's very easy to get it sorted and just ask me. Okay, so that's one of the tools that we can use, and one of the sites that we use is called MathSpot, and the link is there. That's a great one for you to put on the screen when students come in. And you'll see at the top we've got the whole range of metric prefixes, but I've just picked milli and centi here. I can change the number of rows, but I've just set it to 3. You can decide by clicking on here as to which one it is that you want, to show, and then you can be asking students. And as you can see, you've got tools to produce new values and so on. But that's a very easy one click to get that up on the screen, a little bit set up, and that's something that can be on the screen when students walk in the room to give you a very quick overview. All right, so look, I hope I've given you an idea of the scale of the problem and some tools that you can work with. I'm fairly easy to find in college, so my details will be on the handout there. If you're working with students, me or any of my maths team are more than happy to give you a hands-on with some of these, or come to one of my classes or one of my colleagues' classes and see this sort of thing in action. Okay, so thank you for coming this morning. Have we got time for any questions, Sarah? You're on mute, Sarah.
Oh, it's all going swimmingly well this morning, isn't it, Peter? Yeah, fantastic session. Really important that we are embedding maths into our sessions. Yes, we have a responsibility to do so. A couple of responses this morning, Peter. So Sylvia has said digital ruler, a great tool, agreed. And Errol has said excellent session, highlights how the communication between English and maths topics needs to be consistently communicated with main subject areas. Yes, these types of topics could be reinforced and embedded in subject-specific starter activities, for example, as well as embedded into the main content of the lesson. Yeah, and we can do it in kind of many different ways, can't we, embed maths? I'm just thinking, actually, for trainees, we have to do a lot on embedding minimum core, and one of those elements is maths. And I've got a nice little, it's for trainees, but a bit of guidance around how to embed maths, English and ICT, which, so if anyone wants that, I can also kind of share that. It is available on the ETF website as well, but embedded minimum core, but that can also be shared. Annie said very interesting and useful. Saeed saying thank you, Peter, it was very insightful. And Arena, useful online maths tools, thanks. So without further ado, guys, I'll let you go yeah, start embedding some maths into your sessions. Thanks very much, Peter. Take care. Bye.
Thank you all.